This is part 5 in the series in Introduction to the Derivative, and in this session we're going to start with the constant multiple rule. And the constant multiple rule says that the derivative with respect to x of some constant times some function of x equals the constant times the derivative of the function. And to show this with a simple example, let's do the derivative with respect to x of 2x squared. That's going to equal, let's pull out the 2 and take the derivative of the x term. Pull down the exponent, write the x term, subtract 1 from the exponent, which is a 1, and finish. 2 times 2 is 4x. So that's a very basic implementation of the constant multiple rule with the power rule. Let's do another example that's not quite so obvious. Derivative with respect to x of 3 over x. Now, to do this, we're going to rewrite derivative with respect to x of 3 times x to the negative 1. And when we take that derivative, we will have 3 times, pull down the exponent, negative 1, times x, subtract 1 from the exponent, and then simplify. So this gives us negative 3 over x squared. So let's change it up a little bit. So let's say that f of x is 4x squared over 5. Then we'll rewrite this 4/5 times x squared, and f prime will be 4/5 times, pull down the 2, x, subtract 1. 4 times 2 is 8 over 5 x, 8/5 x. Again, in each one of these cases, we're pulling out the constant, doing the derivative, and then recombining at the end. So let's work another example. Let's say y equals 2 square roots of x. So to rewrite this one, we'll have 2x to the 1/2, and to take the derivative, y prime is 2 times, pull down the exponent, 1/2 x, subtract 1, 1/2 minus 2/2 is negative 1/2. And to simplify this, 2 divided by 2, these guys go away. So we simply have 1 over x squared. Not too obvious a problem, but not too difficult. Let's try one more over here. Y equals 5 over 2x to the 3rd. Okay, so let's go ahead and rewrite this. This is actually going to be 5 over 8x to the third, which is, again, 5/8 x to the negative 3. So now y prime is going to be, pull out the constant, 5/8, pull down the exponent, negative 3x, subtract 1, negative 4, which gives us, finally, negative 3 times 5 is negative 15 over 8x to the fourth. And that's our final result. Next, we're going to look at the sum and difference rules. The sum rule of differentiation says that the derivative with respect to x of some function f of x plus some function g of x equals the derivative of f plus the derivative of g. Pretty basic. And this difference rule says the same thing, only using differences. Minus g of x is f prime of x minus g prime of x. You may wonder, what is it that we're talking about here? Let's take a look at a fairly simple example. Y equals 2x squared plus 3x. Now, if we relate this to this expression up here, we can consider this our function f and this our function g. So to find y prime, we would simply differentiate each as though it were a separate function. So pull down the 2, so that's 2 times 2 is 4, subtract 1 from the exponent, 4x, plus pull down the exponent, 3 times 1 is just 3, subtract 1 from the exponent, it's 0, x to the 0 is just 1, 3 times 1 is 3. So there's our derivative using the sum rule. So let's work another one, and we'll say this is g of x equals negative x to the fourth over 2 plus 3x to the third minus 2x. So differentiating the first piece, we'll say g prime equals, let's pull out the 1/2, so negative 1/2 times, we'll bring down the 4x, subtract 1 to the third. Then the next one, plus 3 times, pull down the exponent, 3x, subtract 1 from the 3 squared, minus, do the same thing, pull down the 1, 2 times 1 is just 2, and when we subtract 1 from this exponent, it's x to the 0, x to the 0 is 1, so there's no x down here. Now to simplify this, we would say 4 divided by 2 is 2, so that's negative 2x to the third plus 3 times 3 is 9x squared minus 2. Now we're going to look at one of the other very important rules called the product rule. And the product rule states the derivative with respect to x of some function f times some other function g equals f of x times the derivative of g plus g of x times the derivative of f. Now the way I like to think of this is if we let f of x be equal to u and g of x equal to v, then what we end up having is u dv plus v du. That is the original function f times the derivative of the second function plus the second function times the derivative of the first. So either way you want to look at it, it's up to you, but that is the product rule. So let's see how it's used. So let's start out with a really simple function, and we'll call it h of x equals 2x times x squared plus 3. Now, to take the derivative, h prime of x, we'll have u 2x dv, so the derivative of this is 2x, plus v, this function, x squared plus 3, times the derivative of the first, which is just 2. Now we simplify. 2x times 2x is 4x squared, plus 2 times x squared is 2x squared. 2 times 3 is 6. 4x squared plus 2x squared is 6x squared plus 6. And we can go ahead and factor out the 6, and we have x squared plus 1. And that's our final result. Now, it might have been easier, in fact it would have been easier, if before we did the product rule, if we just multiplied through by each one of these terms. But I wanted to start out with a very basic expression to show you how the product rule worked so that you can apply it to a more difficult problem in the future. But just for kicks and grins, let's go ahead and multiply it through and see how much easier it would have been. 2x times x squared is 2x to the third. 2x times 3 is plus 6x. So taking the derivative, this would be 6x squared plus 6. And factoring out the 6, we would have x squared plus 1, which is the same result. Now, this was not particularly proper, because what I should have done is I should have had h of x equals that, and h prime of x equals that. Always remember to label each thing that you do, just in case your teacher wants you to show your work. You want to know that this is what you've done. In the next session, we're going to look at the quotient rule.